let's look at the law of cosines. All right, law of cosines can be used if you know two sides and the included angle, or if you know all three sides. So we'll look at a couple of examples with that. The included angle, remember, is the angle in between the two sides. All right. Okay, don't freak out. Let's go back and look. We've got our same triangle here, the same setup here, where side A is across from angle A. Side little b there is across from angle B, and side C is across from C. So it's the same setup as the law of sines, but this is going to be the formula here. Now, if you look closely at this, this is not three different formulas. It's just the same formula written three different ways, but it's just really just one formula here, okay? And so if you notice, it might be hard to try to remember this, but if you notice here, if you have a squared, that means you're going to take this side will equal the other two sides squared and added together, and then you're going to subtract 2 times each one of these sides again times the cosine of the angle that was across from where you started. If you look at these other ones, it's the same exact thing, but just from a different side. So if you do b squared, it's going to be what? Equals a squared plus c squared minus 2 times a times c and the cosine of b. And the other one is exactly the same, but just starting from this side, c squared would equal a squared plus b squared minus 2 times a times b, and then the cosine of c. So it's the same pattern, it's just over 3 different ways depending on what side you start from. So if you can just remember kind of how it goes, generally it doesn't really matter what side you start from as long as you know kind of the pattern from here. So let's see how we can do this, and we'll work on a few examples. All right. Didn't touch it. All right, so if you notice here, now, okay, here's the question you're probably going to ask me right now. Well, how do I know where to start at, Mr. Anderson? Okay, what I think is the best way to do this is look at the angle that you have. Okay, notice we only have one angle. Okay, so I'm going to look at this angle, and since in the formula, in the law of cosines, you have to do the cosine of an angle. This is the angle that has to be the cosine of that we're going to take the cosine of this angle, is the way I should say it. So if you notice, let me go back here. If you notice, like on this one, the cosine of A, what did we start with over here? A squared. Here was the cosine of B. Where did we start? B squared. Here was the cosine of C. Where did we start? C squared. So that's where we're going to start, the side that we're going to start on. Okay, so if 45 degrees is what I have, go straight across from this, it's side X. This is where I'm going to start from. So I'm going to say this is X squared equals, now what happens is it's going to be each one of these squared. So I'm going to have 11 squared plus 25 squared. Okay, what I like to think of there is that's just like the Pythagorean theorem. A squared plus b squared equals c squared. Okay, but there's a little bit more. You're going to go minus 2 times each one of these numbers again. So 11 and 25. And then it's times the cosine of the angle that you started with, 45. All right, so that's basically just plugging stuff into that formula. Now we need to type in all the numbers and work it out here. All right, so I'll move it to right there. 11 squared is 121. 25 squared is 625. Here, we're just going to multiply 2 times 11 times 25, so 2 times 11 times 25. So that's 550 cosine of 45. Okay, so I've squared these things, I've multiplied these things together. What can I do next? I can add these two. 121 plus 625. So that's 746 minus 550 cosine of 45. Now, what some of you may be thinking is, hey, why don't you just take the 746 and subtract 550? Well, the reason why we can't do that is because the 550 is being multiplied times the cosine of 45. So remember, you can only combine like terms. If you remember back into the days, oh, the fun days of Algebra 1, when you had 4x plus 5x, you could make it 9x. But if you had 4x plus 5y, you had to keep them separate. Well, that's what's happening here with the 746 and the negative 550 cosine 45. We have to keep those separate because the 550 is being multiplied times cosine 45. All right, so I want to try to find out what x is. Well, what undoes squaring something? Oh, taking the square root. So we will take the square root of all this so that we get x. So we have x is the square root of 746 minus 550 times the cosine of 45. We're going to type that into our calculator. Okay, so we're going to go second function, square root, 746. This calculator's a little finicky. 746 minus 550 times the cosine of 45. And so, what did it say? Round to the nearest tenth. And so it looks like that's going to be then 18.9. Yeah, 18.9. Okay. Now, hopefully you kind of followed through all these steps here. You know, most of the steps was just some basic algebra stuff and then taking square root and square are opposites of each other and then typing this into our calculator. The trickiest part is remembering this formula and setting that up at the beginning. All right, let's do another one. Okay, now this time it's a slightly different because we have side, side, side. We have all three sides. But what it's asking for here is to find the measure of angle L. So we're trying to find this angle right here. Okay, well, Mr. Anderson, what do I do now? Well, if we're trying to find the measure of angle L, remember we started with the angle on the other one because we're going to have to take the cosine of that angle. Well, this is the angle we want to find, so this is the one we're going to start with. So from this angle, go straight across. So this is the side that we want to start with, the 24, okay? So remember, the pattern here is you're going to take that side, 24 squared, equals each one of the other two sides squared. So 5 squared plus 27 squared. Then remember, it goes minus 2 times each one of these sides again, so 5 and 27. And then the cosine of the angle, which we don't know. That's what we don't know, so that's the cosine of L. So notice now we have all these are numbers here, and the L is what we're going to try to find. So remember, if you remember back with our trig stuff a few sections ago, we're going to end up doing an inverse sign, I believe here. Anyway, let's see how it comes out. All right, 24 squared. Let me get the calculator back up. 24 squared is 576. 5 squared is 25. And 27 squared is 729. Now here we're going to just multiply 2 times 5 times 27. So 270 times the cosine of L. Okay, what else can we do? Well, we can combine these two numbers here. So I have 576 equals 25 plus 729, so 754 minus 270 times the cosine of L. Okay, again, notice you're going to be tempted to subtract this, but don't do it because the 270 is being multiplied times the cosine of L. So leave it like that. Don't combine those. What can I do next? Well, we're going to try to get this L by itself. And so, again, this is just basic algebra, just in a little bit more complicated form. But this would be the same thing as instead of negative 270 cosine L, let's say it would be 5x. And this would be like 10. So it'd be like saying 10 minus 5x. What would you do? Get rid of this number first. So minus 754. So I'm going to have now 576 minus 754, or 754, negative 178 equals a negative 270 cosine L. Okay, remember, so we have something being multiplied times the cosine of L. So let's divide by that number. Divide by negative 270. And so let's just do this. The negatives will cancel out. So let's just call this 178 over 270 equals the cosine of L. And then remember what I said before. We have the cosine of L, and so remember, how do we get L by itself? Let's move this cosine over, and remember that's going to be the inverse cosine there. So what's going to happen here is we're going to have, I'm just going to write this kind of, switch the order here. So we're going to find angle L here. The measure of angle L will equal the inverse cosine of 178 over 270. So that's what I'm going to type into my calculator. Second function, cosine, that gives you the inverse 178 divided by 270. And that looks like we've got 48.75, so forth. And so round to the nearest degree. So we're just going to round that to 49. So the measure of angle L equals approximately 49 degrees. Okay. So there's a lot of steps there. Just, as I went through it, I kind of went slowly and added stuff. I didn't try to do stuff in my head for the most part, but just do it step by step. The steps are just basic algebra steps, but it's a little more complicated because of all the cosine and all the numbers here. But just go step by step, just one step at a time. All right, one more thing here. There it is. Last thing, solve the triangle, and we're going to round to the nearest degree. Okay, well, in this case, what does it mean, solve the triangle? Remember, like in the last section, when it says solve the triangle, you're just going to find everything that's missing. Well, in this case, we happen to know all three sides. So what we're going to solve is we're going to find all three angles. Okay, so how do we start? Well, let's just pick an angle to start with. I'm going to just pick Q. I don't know why. But we're going to start with Q. So if I'm going to start with Q, that means I'm going to have to do the law of cosines. So because I don't have any angles here, I just have three sides. And notice with three sides, we can find an angle using the law of cosines like we just did. So I'm going to start, if I'm going to find Q, that means I'm going to start with the side that's like straight across from it, so 7. So I'm going to do 7 squared equals each one of these squared, 8 squared plus 9 squared, minus 2 times each one of these other sides again, so 9 and 8, times the cosine of the angle I'm trying to find, Q. This is like the problem that we just did. So 49 equals 64 plus 81. And then it's late. I'm going to just go ahead and type this in, make sure. 2 times 9 times 8 is 144. Cosine of Q. So let's add these two together. 64 plus 81 is 145. Again, don't be tempted to do 145 minus 144. They're separate, so leave them. So minus 145 to move it to the other side. 49 minus 145. I just can't type these in quick. It doesn't get them. Negative 96 equals negative 144 cosine of Q. Divide by negative 144. So again, we can just drop the negative since they'll cancel out. So this is just 96 over 144 equals the cosine of Q. Remember, to get Q by itself, we're going to do the inverse cosine. So the measure of angle Q is the inverse cosine of 96 over 144. So second function cosine, 96 divided by 144. And that's going to give me about 4, it said round to the nearest degree, so we're going to call that 48 degrees. So the measure of angle Q is approximately 48. Okay? I'm going to write this in, 48. All right, so now that I know that that's 48, what can I do? Well, if I wanted to, I could go through all this again and use the law of cosines and do the same kind of work for one of these other two angles. Or this would be another situation where I could do the law of sines. So let's do the law of sines so we get some more practice with that. Plus, it might be a little simpler than this. So, well, remember how we matched it up with the law of sines? We got the angle matches up with that side. So we could say here the sine of 48 over 7 would equal what? Well, what angle do you want to find? I don't know. Let's find P. So if we try to find P next, we'll try to find this one next. That matches up with the side that's 8 over here, right? So we'll say the sine of P over 8. Okay, cross multiply. 7 times the sine of P would equal 8 times the sine of 48. We're trying to get P by itself. So first of all, get rid of the number in front of it, the 7, so divide by 7. So we have the sine of P would equal 8 times the sine of 48 over 7. That's a 7. And then remember, sine of P, when we move that sine over to get P by itself, remember that's the inverse sine, so that means the measure of angle P will equal the inverse sine of all of this stuff. 8 times the sine of 48 all over 7. Okay. Calculator, let me move it over here. And so let's type this in here. Second function sine, and then second function sine, so that's inverse sine of 8 times the sine of 48, and close parentheses divided by 7. Close parentheses, and That looks like that's going to be about 58. And so the measure of angle P is about 58. And fortunately, if this, where's my thing, 58. And so to find what's left, we just know there has to be 180 degrees, right? So we're just going to do 180 minus 58 minus 48. And so 180 minus 58 minus 58 minus 48 would equal 74. And so that's your measure of angle R is 74. There you go. A lot of work on that one, but you got a chance there to see how to do law of cosines again, law of sines, and then the simple one, just subtract it from 180. That's it. So there's law of sines, law of cosines. Appreciate you being with me today in section 8.6. This is Mr. Anderson, and I will see you next time on geometry.